Good morning and good afternoon, and welcome to this video on forces in motion, unraveling Newton's laws. Now, real quick before we really get into things, I want you to think about what do you know about Newton's three laws? Now, keep this specific, not about Mr. Newton himself, but what do you know about his three laws? Maybe you know something about inertia. Maybe you know something about objects in motion. Or maybe you know something about gravity or something like that. And those are definitely valid points to some of the ideas that Newton brought to us. So let's explore some things in further details. Before we get into things, I want to think about, and I want you guys to think about, what is scientific law? And we're going to compare scientific law with scientific theory in just a moment, all right? So first we have to establish what is law. Well, law itself, okay, when you think about law, and when most people think about law, I'm going to read this directly right from our bullet point here. It's the system of rules which a particular country or community recognizes as regulating the actions of its members, which it may enforce by the imposition of penalties. So think about our current state of laws here in the United States, right? We have federal government that oversees certain things. We have the state of Florida that oversees certain things. And then we have our local community that oversees certain things, right? We have police officers that are usually for the city. We have sheriff's officers that are for the county. And then, of course, we got the Florida Highway Patrol for the whole state of Florida. And then we also have other enforcement stuff through like the FBI and so on and so forth. So that's a quick and easy way to think about it, at least for sixth grade. Next, we're going to think about then, how does that tie in with scientific law? Well, if law is systems and rules that regulate something, specifically people, laws then can be something that regulates how things work together. So let's read the statement together real quick. Scientific law, in its most easiest to understand form, are statements based on repeated experiments or observations that describe or predict a range of natural phenomena. They are usually universal. In other words, they apply to everything. They're usually kind of simple. You see it, you get it, all right? They're usually absolute. In other words, they always happen. All right. They are stable. In other words, you're not going to have any variations with it. And of course, they're always valid. Some people would consider the law of gravity. We're going to debate that here in a few moments. Okay. And then there's definitely a law of conservation of energy. Now, if you're in the sixth grade saying, wait a minute, Mr. Cato, you're wrong. There is a law of gravity. We're going to explain that in simple forms here in a few moments. Next, we have scientific theory. All right, scientific theory is a well-supported explanation of how nature is supported by, or how explanation of nature and is supported by substantial evidence. All right, so we have, you can read this on your own here as I'm talking, or you can pause it. But basically, you have the idea here that a theory is kind of like an explanation on what we observe, all right? They tell us what happens, as opposed to what is not what is going to happen, but what happens. In other words, what's making something occur, all right? So we were just talking about Newton's, quote, law of gravity. Well, believe it or not, Mr. Einstein, all right, disproved the law and turned it more into a theory. So it's not really disproving a law, it's just reshaping what we think about it, okay? So his theory of gravity, relativity, said something else about gravity, all right? And it's more of a force that acts as a distance, okay? I'm sorry, let me rephrase that. Newton had explained that gravity is a force that instantly acts over a distance, all right? However, Einstein thought of it a little bit differently. Let's take a look at that, all right? All right, so Mr. Einstein himself, right? He thought of relativity, all right? So basically, what I want you to think about in terms of relativity is that relativity means that we see things differently from our point of view, okay? So say like you're moving on a bus. The things that happen around you, not just with the people, but maybe when you toss an object, will be different on the bus than saying tossing an object from the sidewalk, okay? Or doing that from a sidewalk. While you're tossing an object, say up and down in your hands on a moving bus, all right, that ball is moving not only up and down, but it is moving with the motion of the bus itself. As opposed to being on the sidewalk tossing a ball up and down, it's just simply going up and down. All right, now think of that, how that relates into the relation of the rotation of the earth. All righty. So he thought about relativity. All right. So in terms of gravity, Einstein said that gravity isn't a force pulling things down, but is instead bending space around them. And the closer you get to an object, the more gravity you feel. Okay. Again, relativity. Okay. So it's a little bit different way of thinking about it. Again, as you saw here, laws describe what happens, all right, while theories explain why it's happening. Laws are more mathematical. If this and this, you're going to get this. Theories kind of say things are a little bit different. Let's continue here. So there was Sir Isaac Newton, who we contribute the 3 laws with, all right? And he was a pretty smart dude and considered by many to be one of history's greatest scientists. He was born in 1643, so that means he was born about 380 years ago. And he collected his thoughts and his observations and worked on them in his lab or in his study area. And basically, he described motions and forces, and then put all of his observations into a book called Principia Mathematica, which is Latin for Principles of Mathematics. And this book was written in Latin because that's the way that books were written back then, all right? But he was smart enough where he was working on calculus, optics, in other words, the study of lenses and how lenses work, so like we see over distances, say through like telescopes and such, and of course, gravity. All right, so we're going to be looking at 3 different laws. The first law we're going to look at is the law of inertia, and that'll come in the next video. The video after that, we're going to look at a second law, and we're going to look at force, and then, of course, we're going to look at action and reaction in the video following. And then we're going to summarize everything after that. All right, so why do Newton's laws matter? Well, it's pretty simple. Newton's laws help us understand the world around us. All right, they're not just ideas for a textbook and for you to regurgitate on, say, like a test. All right, they affect our lives. Think about this. Okay, let's just take this first part, all right? Helping engineers design safer vehicles. If we understand how our bodies work and how motion works, we can understand and design safer vehicles. Seatbelt, for instance, right? Is it better for a seatbelt to give a little bit and then lock up, or to lock up right away? Well, if we understand how motion works, okay, with Newton's laws, okay, an object in motion tends to stay in motion, we're going to look at that, then think about our organs in our body, all right? If we're having to stop at a certain speed, okay, how are our organs reacting to that, okay? We also use Newton's laws in sports and athletics for those who are interested in the athletics field. And that's used all over the place, from maybe the way we toss a ball, maybe the way that the resistance or the friction reacts against the threads of a baseball, or the way that ball is spinning. How about the way that you throw a football? All right, does it have a nice spiral on it, or are you throwing a lame duck? Okay, maybe about basketball and calculating trajectory and arc. Okay, It is critical for space exploration, absolutely, because if we don't understand physics, in other words, how the world operates and all those things, it's going to be very difficult for us to do simple things, and I say simple things, to do things like put something in orbit or to go to the moon or go even further than that, as we have plans for here for the U.S. in the future. And they help explain everyday experiences. All right, why does a car squeal when you try to stop it too much or stop too fast? Why does a sprinter not immediately stop running as he's trying to slow down, and it takes a lot of effort to get that body to slow down? That sort of thing. Alrighty, so I'm going to leave you with those ideas for this video, and then look for my second video when we're going to start looking at inertia.